Hi, it's Mr. Crane here. We're on day 2 of our solar system scale model calculations, and I'm making the second video to be an addition to yesterday's video. So hopefully this will be a tutorial guide for you to help you get through the science and math calculations for this particular solar system project. Now, virtual students, you don't have to make your planet. You're more than welcome to. Once you figure out your diameters and distances and everything, you're more than welcome to. But it's not a requirement just because you are on limited resources. So, if anything, I need you to make sure that you 100% get through the material that we discuss in these tutorials. Okay? So, today is part 2. So, I'm going to pull up the document and I have a whiteboard ready to go too. So here's the document again from yesterday, 17B solar system, same assignment as last week, just I'm helping you with the math. So here was the math for yesterday to figure out our relative distances from the sun of each planet. Here's each planet, and this is a data chart you should have filled out yesterday. Today, we're on part 2. So we're on part 2, and we're going to talk about diameters. Now, we'll answer these questions right here on Wednesday or Thursday. I don't remember what day I have set aside for that, but don't worry about those right now. Let's go to part 2 of our determining scale sizes of the planets. So now we did distances yesterday, so distances from the sun over to Neptune, and put that on our football field where you think it would be on the football field. Today we're going to do diameters, scale diameter. How big is the planet itself? Now, luckily, we're going to use the same equation that we figured up yesterday. So it's going to be a shortcut. I'll go run through it real quick just so that you understand it again. But today we're just going to do the diameters. So here's the actual diameters that you'll be using, and you'll be trying to come up with a scale diameter, and then that you can see that that's in meters, but we have to convert it to millimeters. So I'll go over a little quick shortcut for you on how to figure that. It's really simple. You just move the decimal over 3 spaces to the right, but I'll show you how to determine that where it makes sense and you actually understand it. So let's get started. So I've created a document right here. Yesterday we started this, and it's 100 meter. This is our football field. So this is our football field right here, where it's 100 meters is equal to 4,500,000,000 meters, or kilometers, sorry. And that's the distance from the sun to Neptune. So from goalpost to goalpost. So from goalpost here to goalpost here. All right. So yesterday, I'm going to have to hold on to the computer screen. So yesterday we looked at this relationship of 100 is to 4,500,000,000. So I'm going to recreate what we did yesterday really fast as I can. So that equality, I'll extend it out, is equal to the number we're looking for in your data chart. So the actual scale distance or diameters for today. So we're on diameters today. So this is the scale diameters. So what we're looking for and our actual diameter. All right. So when we set up an equality like this, there's an easy way to do this. You just simply cross multiply because one side is equal to the other. So when we cross multiply this, we get 4,500,000,000. Those are zeros. Kilometers. 4,500,000,000 kilometers times x equals 100 times our actual. All right. Hopefully I can put that in there. Actual. I'm running out of screen. Actual. All right. It's supposed to be a U. That's terrible. Just know that that box means actual. All right. So now we need to solve for x. When we do that, we have x over here. So we need to get this 4,500,000,000 by itself. And because they're multiplying by each other, 4,500,000,000 times x, if I divide by 4,500,000,000, then I can cancel those out because that's actually 1. I'm multiplying it by 1. Anything over itself is 1. But what I do to one side, I must do to the other side. So I'm going to divide by the other side. All right. All right. So now I have my equation that we're looking for. So here's the, oops, did not mean to do that. I don't know how to get rid of that. Sorry. So this is our, what is wrong with that? So this is what we're looking for. So if I look at our data from our data chart for today, and we're going to use this one here, and you can follow along with the same thing I'm doing right here. So if I pick a given number here, so for instance, Mercury is 4,480 kilometers wide. So when I'm talking about diameter, remember that I'm talking about here's my planet. So across its equator, Mercury is, and I've forgotten already, Mercury is 4,880 kilometers. So 4,880 kilometers. All right. So I put that into my equation over here, 100 times my actual. We're putting 4,880 divided by 4,500,000,000. All right, so you multiply 100 times the 4,880 kilometers, divide that by 4,500,000,000, and you're going to come up with a number that, if you look back at your chart in the example, it's 0.000, so 3 zeros and 108. 0.000108. All right. Now that's in meters. So now that's where I would, whenever I find Mercury, say Mercury is right there. Mercury's right there. Whenever I find my object, it would be in the same scale, in the meters kilometer scale. It would be 0.000108. Now that's really tiny. The smallest that the human eye can see is 0.1 millimeters. So that's the smallest that the human eye can see. There's my lashes on that. So that's pretty tiny. In fact, that is much smaller than the human eye can see. Actually, it's 0.0 m. We're going to determine how many by looking at our scale. We're going to see how many millimeters that is. So let's look at real quick. This is my last thing to teach you for today. So we all learned at some point this wonderful stair step lesson. And if I said, use this little acronym called King Henry died, that's a D, by, small d, drinking chocolate milk. All right. Now B is equal to our base, and our base could be grams, meters, liters. And in this term, in this sense, we are at meters. So let's look at that. So I know that because it says meters right there. All right. So 0.08 meters is going to start me at my base right here. All right. So if I'm starting here and I'm trying to go to millimeters, I'll show you how I know that it's millimeters, is because right there it says millimeters. So I'm going from meters to millimeters. Once in the direction I move, whether it's up or down the stairs, is the direction I move, my decimal point. So I'm going to millimeters, which is here. So that's 1 step down, 2 steps down, 3 steps down to there. That's where I'm going to, and I moved to the right when I did that. So I moved my decimal points the same number of steps I took. So I moved that 1, 2, 3 steps to the right. So right here's my decimal point. I need to move that 3 spaces to the right. 1, 2, 3. So now my millimeters number is going to be 0.108. So then that's millimeters. So for you, when you're over here filling out your chart, the only thing you have to do is take your decimal point and actually move it over 3 places to the side, and that number right there would be 0.0, no, 0.108, because we moved it over 3 spaces. All right, and that's millimeters. So that's how you do this, and you do that for each one. So instead of it being 4,880, you're going to use the sun for this one. You're going to put that in the actual 1,391,980. So over here, you're going to, right here, you're going to take that out. So you're going to substitute whatever that is, substitute, sub out that 4,880 for whatever the actual diameter is for the sun. So that should help you out. Follow that, rewind this, pause it, whatever you need to do so that you understand this. Walk through every one of those, and I'll see you tomorrow with the next tutorial. Bye. I got to close it out. Sorry. So right there. I think I'm still recording. Come on, stop recording.